Now we want to go to another graph. The previous graphs, we had distance time graph, but this one is speed time graph. Are they the same? Can we describe this? Can you describe this graph? Okay, try to focus, please. Look at this. Here, we want to describe it. In the beginning here, when time is 0, the speed was, of course, 0. Okay, what happens to the speed between 0 and 10? Between 0 and 10. Look at the speed. The speed is increasing. The speed increases. Look. It increases from 0 to reach 16 after 10 seconds. Good. What about this? Here. What about in this point or in this segment? Between time 10 seconds to 20 seconds. During these 10 seconds, what happens to the speed? You remember the distance. Does it increase? No. Does it decrease? No. This means the speed here does not change. This means we have a constant speed. Good. What happens between 20 seconds and 25 seconds? Look, the speed was 16. And what happens to it here? Excellent. The speed decreases, or the object slows down, okay, between time 20 to 25 seconds. It decreases from 16 to 0. This means the object stops, or the object becomes at rest after 25 seconds. Now, is this graph the same as the distance time graph? Of course not. They are different. Why? Because on y-axis here we have speed. So we see here what happens to the speed when time changes. Good. Can you describe what happens to the speed of the object in these graphs? Or which graph represents the object in this, or the car in this question? Good. Which graph here represents a car moving with a constant moving, or moves with a constant speed, and then constant acceleration? Okay, in the beginning here, in figure A, look at this. In the beginning, the speed increases. This means the object here is moving at acceleration. Okay, and after that, the speed becomes constant. Okay, but they said here, a constant speed in the beginning. So this one is not used here. What about this one? This one, they said moves, but here the speed is 0. This means it is at rest. So this one, we cannot use it. What about this one? Constant speed. Yes, look at this. The speed doesn't increase or decrease. After that, it increases. This means we have here a constant speed, but we have here acceleration. The speed here, this one, I think it will be the correct one. The speed here, what happens? Look, it decreases as time passes and became constant. Okay, so they said here constant speed in the beginning. The only one which has a constant speed in the beginning is C, and after that, acceleration. Why did we say here a constant acceleration? Because you know acceleration equals a change in velocity or speed divided by time interval. As time changes, the speed changes. This means we have acceleration. So we have acceleration here, we have acceleration here, we have acceleration here, we have acceleration here. We have here a straight line, straight line, straight line, straight line. This means the speed changes regularly with the time. This means we have here a constant acceleration. In these straight lines, we have a constant acceleration. Good. But look at D. The speed decreases, so we have here a deceleration. Good. But in A, B, and C, we have a positive acceleration because the speed increases as time changes. Good. Can we get the acceleration from speed time graph? Of course, yes. How can we get it? Again, acceleration equals change in velocity in unit time or per unit time. Good. This means it equals the change in y over the change in x. Great. This means also the acceleration equals the gradient. Why? Because it equals the change in y over the change in x. It equals the change in y over the change in x. This means it equals the gradient. So if we get the gradient here, which is rise over run, this means we can get the acceleration. Okay, look at this. Rise over run is the gradient, and if we get it, we can get the acceleration. Brilliant. If we want to get the acceleration for each segment here, this one is the velocity or speed in meter per second or meter second per -1. This is the rise, this is the run. I think we can get the acceleration. The rise is from 0 to 3. The run is from 0 to 2. So it is 3 minus 0 over 2 minus 0. I think you can get it. Okay. For this one, for this segment, can we get the acceleration? Of course, yes, because the speed does not change. This means no acceleration. What about this one? We have here a deceleration. In this one, because the speed decreases. The speed here decreases. Can we get it? Of course, yes. Look at this. We have here the rise over the run. The rise changes from 3 to 0, from 3 to 0. So it is 0 minus 3, this one, over. The run is from 5 to 8, so it is 8 minus 5. So it equals -3 over 3 equals -1 meter per second squared. Okay, or meter second per -2. Can we get the acceleration for this one? Try to get the acceleration at least for the first one. And tell me. Okay. Look at this. We have here another graph. Please look at it carefully. What happens here? The object is accelerating. Brilliant. Here, the speed is constant. This means zero acceleration. What happens here? Again, accelerating. Here, the object is decelerating. Look at them again. Can we get the acceleration for each of the 4 sections? Can you get the acceleration in this segment, okay, in the 4 segments? Please try to get them, and I will show you the answers. Are your answers correct? Good. Back to this one. Can you describe the motion in each of these graphs? Tell me. We have here distance, time graph. This means what happens to the distance as time it changes? The distance it changes. This means we have here a speed. Is this a straight line or a curved line? Straight line. This means this speed is constant speed. The object does not speed up or slow down. Look at this one. What is on y-axis? It is a speed. What happens to it as time passes? The speed increases. So in this case, the object is accelerating. This means the object is speeding up. So now the graphs seem to be the same, but they are not the same. I have here a constant speed, but I have here an object which is speeding up or accelerating. Hope you understand. I think this is easy to get the speed in each stage. Look at this. This is the distance, and this is the time. Is it easy? Can you calculate the speed? Good. What about this one? Please try to answer this one, and I will answer it after a while. Good. Look at this one. Look at the graph and try to match these. Okay. From W to X, this one. From W to X here. What is on Y-axis again? It is the speed. What is on X-axis? It is time. The speed, what happens to the speed from W to X? Look at this. The speed increases as time passes. This means the object is accelerating, or the speed increases. So from W to X, the object is accelerating. Good. From X to Y, does the speed increase? No. Does it decrease? No. This means the object does not speed up or slow down. This means the acceleration here is 0, or we have here a constant speed. Okay, so from X to Y, the object has a constant speed. From Y to Z, from Y to Z, the speed starts with 20 and ends with with 0 here. This means the object is slowing down, or you can say that the object is decelerating. So we have here from Y to Z, the object is decelerating. What about stationary? Stationary means the object is not moving. Not moving means the speed is 0. And they got it to be confused from X to Y. If we have here on Y-axis, if we have distance, this means yes, from X to Y, it is stationary. But what is on Y-axis here is the speed. This means the object is moving at a constant speed. Look at this one and try to describe. Okay, in P, and section P, what happens to the speed? Of course, yes, the speed is increasing. This means it is accelerating at constant acceleration here. Okay, we have here a constant acceleration. Why constant acceleration? Because it is a straight line between speed and time. The speed changes. This means we have acceleration, and it changes regularly at a straight line. This means we have constant acceleration. What about Q? The speed doesn't change. This means we have a constant speed, or 0 acceleration. What about R? The speed decreases. Good. This means we have here deceleration. But this deceleration is not constant because it is not a straight line. What about S? The speed at S is 0. This means the object at S is stationary. Okay. I think it is clear now. Look at another part here, which is how to calculate the distance using speed time graph. Look at this one. If I have a speed time graph like this, and I want to get the distance, can we get the distance from this graph? Remember again, speed equals distance over time. If we have this triangle, the speed equals distance over time. This means distance equals speed time time. Where is the speed here? The speed is on Y-axis. Where's time on X-axis? If we are calculating a quantity which equals y multiplied by x, these two are multiplied. This means if we want to get a quantity equals y multiplied by x, we have to get the area under the graph. So the distance in this case equals the area under the graph. All of this area we can get. We have to get the distance. Okay, look here. The distance equals speed time time. This means the distance equals the area under the graph. How to get the area here? Look at this. We can get the area. We can divide it into a rectangle and a triangle. We can get the area of the rectangle and we can get the area of the triangle. Now we can get the distance. This distance equals here. Look at this. 5 times 4. This is the area of the rectangle. 5 length times width. And that triangle equals, the area of triangle equals half base times height. The base is 5, the height is 10. So it is half times 5 times 10. So this means it is 25 times 4 plus 25. So it equals 45 meters. Good. Let's see another thing. The acceleration of free fall. Look here. If an object is falling and there is no air resistance, this object is falling at a constant acceleration. You know that if the object is falling, if we want to draw a graph of an object which is falling and there is no air resistance, there is no air. This is the speed and this is the time. The object speeds up at a constant acceleration. This constant acceleration is the acceleration of free fall. And the acceleration of free fall, g, is 9.8 meter per second squared. Again, all objects fall at the same acceleration, which is 9.8 meter per second squared, if there is no air resistance or in absence of air resistance. And the air resistance is called the drag. Okay, again, the acceleration of free fall or the acceleration due to gravity, which is g, because sometimes it is called acceleration of free fall and acceleration due to gravity. This acceleration is about 9.8 meter per second squared. Again, this acceleration is equal near the Earth's surface or all over the Earth's surface, approximately equal. What if we have air resistance? Imagine we have here a skydiver. When he jumps from the airplane, he speeds up because of the gravity. Excellent. But because we have here air, it opposes the weight of the object. The object is falling due to the gravity or due to the weight, and the weight is the same everywhere here. But when he falls, the air resistance starts to oppose the motion. As the object speeds up, the air resistance increases till the air resistance equals the weight. In this case, the object starts to move at a constant speed. This speed is called terminal velocity. This constant speed is called terminal velocity. All of these are before opening the parachute. What happens after opening the parachute? Look at this. When we open the parachute, the air resistance increases greatly because the surface area increases, so the air resistance increases, so the object starts to slow down. The object decelerates, but still it is moving down. The object slows down, and after that, when the object slows down, the air resistance decreases again till it equals the weight of the object. This is the air resistance again, and this is the weight. This is the weight of the object. And when they become equal, the object reaches a constant speed, which is also called terminal velocity. We have here, this is the graph of a skydiver when he jumps from the plane till he reaches the ground. Look at this. This part is before opening the parachute, and this is after opening the parachute. In the beginning, when he jumps from the plane, when he jumps from airplane here, he starts to accelerate. Look, but the air resistance increases here, so the acceleration decreases till the object or till the skydiver moves at a constant speed, which is the terminal velocity. After opening the parachute, the speed decreases. The speed decreases because the air resistance becomes great, more than the weight. But when the speed decreases, the air resistance also decreases till it becomes equal to the weight of the object. In this case, when the weight equals the air resistance, in this case, the object reaches a constant speed, which is called the terminal velocity in this case. Okay, so we have here the object reaches two terminal velocities, one before opening the parachute and the second after opening the parachute. But in these two cases, the weight is equal to the air resistance or the drag. The weight equals air resistance here and here. This is the end of the lesson. Thank you very much. See you next time, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.